Assalamu alaikum warahmatullahi wabarakatuh. My name is Hassan Abdul Ahmed. Number matric number PE21009. I'm here with group number two, and we're here to present our project electric circuit 2. So I'm here to present question number one. So in the question number one, part A says design your circuit to obtain an over damage, critical damage, and under damage response. For the design, we choose your frequency. So as a group, after we discuss, we choose 700 radian per second in our omega. So as you can see here, we did some mathematical solution for our circuit. So after this, we apply KCL at node X, as you can see. So we get equation number one, and after that we get our equation number two. So combine our equation number one and equation number two, we get omega equal 1 over square root LC as our equation number three. So also we got here our equation number four. So here also we get equation number five. So as I mentioned it before, we choose our omega becomes 700 radian here. So applying here for these equations, we find our inductor 2.04 millihenry, and from equation number 5 we get our resistance 0.7 ohm. So that's it. And in our question number one, part B, says find the expression of PCT and ILT for t bigger or equal 0. So show all your calculations. So as you can see here, we calculate our expression for PCT, and here after we did the calculations. So here also we did IT, ILT, the current inductor with respect to time. After this, we get here the design for any time system. So here we get here our design and our plot graphs. So here is our plot graphs, and this the damage system, this critical damage system, and this over system. So after this, equation one D says analyze the response from part C that will give you shortest time on reaching 80% the final value VCT, and give comment and conclusion. So here we can say that critical damping gives the fastest response among all the damage we have calculated, and these are these calculations for part D. So we get 0.8 equal E over minus 700 C times 700 C. So the comment will be that the value of T here gives the shortest time. So that's all, and wanted to thank my group. Thank you so much, and also thank you TikTok, and this question number one. So thank you all.
Assalamualaikum warahmatullahi wabarakatuh. My name is Luqman Hazim bin Yusri. My matrix number is CE220092, and I will explain question number 2. Question 2A, given sinusoidal sources Vs 50 sin watt V and Is 10 cos watt A, where W equal to 5 grad per S. Solve the steady state currents and voltage expression IA, IB, IC, and VT using any two-circuit analysis technique, either nodal, mesh, source transformation, or others. Question B. Simulate the steady-state currents and voltage IA, IB, IC, and VT, and then compare the result with your calculation in part Q2A. For C, plot the steady-state currents and voltage response IA, IB, IC, and VT. Okay, for the first one, V1 equal to IS times ZLI, which is 10 LO times J 0.5H equal to 5I. Next, we want to find V2. We use V1 over J05 plus V1 minus V2 over 10 minus J100. Then we enter the V1 value, and after we count the value, it will be 9.9 plus J1 99 over 0.1 minus J 0.01. That will be the V2 value, which is 96.05 plus 29.51 I. For I3, we use node analysis, which is V2 minus V3 over J 12.5 minus V3 over negative J 22.22 minus 50 L negative 90 over 20. After we enter the value, the answer will be negative 2.5 I. Then negative 2.36 plus 5.18 I over J 0.72 equal to 0.53 plus 0.24 I. Then the value of I1 will be V1 over 0.5H equal to 10I. I2 equal to V2 over 5 ohm equal to 19.21 plus 5.9 I, and I3 equal to V3 over negative J 22.22 equal to 0.01 plus 0.02. So we simulate the answer with the question. So it will be like this. Then Vs equal to 50 sine WTV equal to 50 minus 90. Is will be 10 cos WTA equal to 10 0, and W will be 5k rads over S. So that's all for question 2. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azran bin Muhammad Nasrun, and today I'm going to simulate the circuit of our assignment. First one, for question 1, is we must simulate the circuit, design in part question 1a, and plot all the response of VC and IT for t more than 0 seconds. And then we should analyze the response from part question 1c that will give the shortest time on reaching the 80% of the initial value of VC and give comment and conclusion. For circuit of our underdamped circuit, we choose the value of R is 0.714 ohms, L is 2.04 and the value of C is 7 millifarad. And for critically damped circuit, our value of R is 100 ohm, 0.4 Henry, and capacitor is 10 microfarad. Lastly, overdamped circuit, R is 300, L is 0.4 Henry, and capacitor is 10 microfarad. After that, we can construct our circuit in the multisim and run the simulation. This is the value that we will get when we run, and using the voltage probe to get the voltage of our circuit 1, circuit 2, and circuit 3. If we want to record the simulation of our current, we must remove the voltage probe from the transient response and put in our current probe to get the output of our current. This is our waveform of current that we got on the underdamped circuit, critically damped circuit, and overdamped circuit. Next is the simulation for question 2. For question 2, we must simulate the steady state currents and voltage of IA, IB, IC, and VT. First, we must construct the circuit the same as the questions given. Next, we put in the value of I as equal to 10 ampere, and then we put the value of V1 or Vs is 50 volt with the phase of negative 90 degree. And then we can start to run the circuit. We can pause the simulation to get an accurate result of our reading of IA, IB, IC, and the value of V total. Next, we need to plot the steady state currents and voltage response, which when we using the grapher, we can get the output of the plot of our steady state currents. This is the plot of our steady state currents of IB, IC, IA, and VT. Thank you for listening.